If you pulled the plug on the Great Lakes and drained them completely, you would not find a flat, sandy bottom. You would find something that looks like another planet. Cliffs taller than skyscrapers, canyons that rival the Grand Canyon, shipwrecks sitting upright with cannons still loaded, stone hunting structures built by humans who walked this land 9,000 years ago, before the glaciers melted and covered them in 120 feet of water, and in some places, human bodies that have been preserved for nearly a century. The Great Lakes hold approximately 20% of the world's surface fresh water. If you combined all 5 lakes, Superior, Michigan, Huron, Erie, and Ontario, you would have enough water to flood the entire continental United States to a depth of nearly 10 feet. The deepest point of Lake Superior is approximately 1,332 feet. If you placed the Empire State Building on the bottom, roof to floor, only the antenna would peak above the surface. At that depth, there is no sunlight. The temperature never rises above 39 degrees Fahrenheit, and the things that sink there do not come back up. There is a saying among sailors on the Great Lakes. It comes from an old Ojibwe legend, later immortalized by Gordon Lightfoot in his ballad about the Edmund Fitzgerald. Superior, they said, never gives up her dead. That is not just poetry, it is biology. This is a tour of the abyss beneath the surface. We are going to walk the ancient seafloor where prehistoric humans once hunted caribou. We will visit underwater stone formations that researchers are still trying to explain. We will see War of 1812 warships sitting upright in 300 feet of water, their cannons still pointed at an enemy that surrendered 2 centuries ago. We will explore underwater sinkholes where life forms identical to those that existed 2.5 billion years ago are thriving today. And we will witness an invasion that is destroying these underwater time capsules faster than anyone ever predicted. The Great Lakes are not just lakes. They are a vault. And what is locked inside is stranger than you would ever imagine. To understand what is at the bottom of the Great Lakes, you have to understand how they got there. The story begins over 1 billion years ago. During the Mesoproterozoic era, the North American continent began to tear itself apart. A massive rift opened up, what geologists now call the Mid-Continent Rift. Magma poured up from the Earth's mantle, forming volcanic basalt ridges that still line the bottom of Lake Superior today. If the rifting had continued, North America would have split in 2. The continent would have had an inland sea running from Minnesota to Alabama. But for reasons that remain unclear, the rifting stopped. The wound in the Earth's crust never fully healed. It just scarred over. That scar became the basin that would eventually hold Lake Superior. Fast forward to approximately 2.5 million years ago. The Pleistocene epoch begins, and with it a series of glacial advances that would reshape the continent. The glaciers were massive, some over 1 mile thick. As they advanced and retreated over tens of thousands of years, they carved out the basins of all 5 Great Lakes. They scraped away sediment, deepened existing river valleys, and deposited moraines, ridges of debris that would eventually form the boundaries between the lakes. The last glacial maximum occurred approximately 20,000 years ago. At that time, the glaciers covered everything. There were no Great Lakes, just ice. Then the warming began. As the glaciers retreated, meltwater pooled in the carved-out basins. The lakes formed gradually, their water levels rising and falling dramatically over thousands of years. Here's the key point. During certain periods of this glacial retreat, the water levels were hundreds of feet lower than they are today. The bottoms of the lakes, now hidden beneath dark, cold water, were once dry land, and people lived there. Lake Superior is the largest, deepest, and coldest of the Great Lakes. It holds approximately 10% of the world's surface fresh water. If you emptied it, you could flood both North and South America to a depth of 1 foot. The Ojibwe called it Gichigami, meaning Great Sea. The French called it Lac Supérieur, the upper lake, because it sits higher in elevation than the others. But what makes Superior truly unusual isn't its size. It's what happens to things that sink into it. At the deepest points, more than 1,300 feet down, the water temperature holds steady at around 39 degrees Fahrenheit, year-round. There is no oxygen, almost no bacteria, almost nothing that causes decay. In warmer bodies of water, when a person drowns, bacteria in the body produce gases as they decompose organic matter. Those gases cause the body to bloat and eventually float to the surface. This is why drowning victims in lakes and rivers are typically recovered within days or weeks. Lake Superior does not work that way. The water is too cold for bacteria to thrive. Without bacterial decomposition, bodies do not produce gas. They do not float. They sink to the bottom and stay there. But it gets stranger. In the cold, oxygen-poor environment at the bottom of Lake Superior, a chemical process called saponification can occur. The fats in a human body react with minerals in the water and transform into a waxy substance called adipocere, sometimes called grave wax or corpse wax. It is remarkably stable. It essentially mummifies the body, preserving it for decades, potentially centuries, in a state of waxy suspension. Lake Superior never gives up her dead. In December 1927, a cargo ship called the steamship Kamloops vanished during a winter storm near Isle Royale. 22 people were aboard. None survived. The Kamloops was carrying a mixed cargo: tar paper, paper-making machinery, coiled wire, shoes. On December 6th, the ship was last seen steaming toward Isle Royale, coated in ice from the storm. Then it disappeared. A search began on December 12th and lasted until December 22nd. Nothing was found. For 50 years, the Kamloops was one of the ghost ships of the Great Lakes, lost without a trace. Then, in August 1977, a group of sport divers found her. The ship was sitting on the lake bottom under more than 260 feet of water, northwest of Isle Royale. It was remarkably intact. Cargo was still in the holds: lifesavers, candy, toothpaste, wooden barrels, all of it preserved, as if the ship had sunk yesterday rather than half a century earlier. But the divers found something else. In the engine room, floating in the darkness, was a human body. The cold water had triggered saponification. The corpse had turned white, pale and waxy, preserved in the frigid depths for 50 years. Divers began calling him Old Whitey. And here's the part that makes the story unsettling. Old Whitey appears to move, not on his own, but when divers enter the engine room, the currents created by their fins disturb the water. The body drifts toward them. It seems to follow them. It is physics, not ghosts. But physics can be terrifying enough. To this day, Old Whitey remains in the Kamloops. No one has removed him. The wreck is considered a grave site, protected under Canadian and American law. The most famous shipwreck in the Great Lakes is the Edmund Fitzgerald. On November 10, 1975, this 729-foot ore freighter sank during a massive storm on Lake Superior. All 29 crew members died. No bodies were ever recovered. The ship left Superior, Wisconsin on November 9th, carrying over 26,000 tons of taconite pellets made of processed iron ore. Captain Ernest McSorley had decades of experience on the Great Lakes. He was aware of a building November storm and took a northerly course to stay protected by the highlands on the Canadian shore. But the storm was worse than anyone predicted. Winds reached 75 knots. Waves swelled to heights of 25 feet. At around 3:30 in the afternoon on November 10th, McSorley radioed that the ship had lost 2 vent covers, a fence railing, and was developing a list. The Fitzgerald had also lost its radar system. At 7:10 in the evening, another ship called the Arthur M. Anderson radioed McSorley for an update. His reply was the last transmission ever received from the Edmund Fitzgerald. "We're holding our own." Minutes later, the Fitzgerald vanished from radar. The ship went down so quickly there was no time to send a distress signal. The ship lies in approximately 530 feet of water, about 17 miles north-northwest of Whitefish Point, Michigan. The wreck broke in two when it hit the bottom, the two pieces lying approximately 170 feet apart. It is protected as a gravesite under Canadian law. The ship's bell was recovered in 1995 and is now displayed at the Great Lakes Shipwreck Museum. A replica engraved with the names of all 29 crew members was placed on the wreck in its place. Every November 10th, the Mariners Church of Detroit tolls its bell 29 times, once for each crew member lost. In 2007, a team of researchers was scanning the bottom of Grand Traverse Bay in Lake Michigan, looking for shipwrecks. They found something else entirely. Dr. Mark Hawley, an underwater archaeologist at Northwestern Michigan College, was using sonar to survey the Grand Traverse Bay underwater preserve. Approximately 40 feet below the surface, the sonar picked up a strange formation, a line of stones stretching over a mile across the sandy lakebed. Some of the stones weighed thousands of pounds. At one end of the line, the stones appeared to form a rough circular pattern. The discovery made international headlines. Journalists called it Michigan's Stonehenge, and the story went viral. But here is what the headlines got wrong. Dr. Hawley has been clear about this. The site is not a henge. The stones are much smaller than the megaliths at Stonehenge, ranging from the size of a basketball to that of a compact car. There is no clear ring or monument structure. What exists is a long line of stones on a sandy bottom where stones do not naturally occur. On his own website, Hawley wrote that this label has been placed on the site by individuals in the press who may have been attempting to generate sensation. The media sensationalized it. The reality is more nuanced and arguably more interesting. One of the stones appears to have a marking that some researchers believe could be a carving of a mastodon, an elephant-like animal that went extinct approximately 10,000 years ago. If confirmed, this would date the site to the end of the last ice age, when the lakebed was dry land and early humans walked where fish swim today. But that is the key phrase, if confirmed. The carving has not been verified by independent scientists. The stone is covered in algae, sediment, and invasive mussels, which make detailed analysis difficult. Dr. Hawley himself has described the mastodon interpretation as unproven. What we can say with more confidence is this: 9,000 years ago, the bottom of Lake Michigan was exposed. The glaciers that carved the Great Lakes were still retreating. Water levels were hundreds of feet lower than today. This was not a lake, it was land, and people lived there. Similar stone structures have been found in neighboring Lake Huron, and those have been more definitively studied. Lake Huron contains something that scientists have called a window to early Earth, an ecosystem so strange, so primitive, that it resembles life as it existed 2.5 billion years ago. But first, let's talk about what else lies beneath its surface. Running across the bottom of Lake Huron, approximately 120 feet below the surface, is a limestone ridge called the Alpena Amberley Ridge. 9,000 years ago, it was not underwater. It was a land bridge connecting what is now Michigan to what is now Ontario, and it was crawling with caribou. In 2014, researchers led by anthropologist John O'Shea at the University of Michigan announced a discovery. An area the size of a football field contained dozens of human-built stone structures, the most complex prehistoric hunting site ever found beneath the Great Lakes. The key feature is called Drop 45 Drive Lane. It consists of two parallel lines of stones leading to a cul-de-sac, a dead end lined with natural cobblestones. This is a hunting structure, a trap, Ancient peoples built these stone lanes to funnel migrating caribou into kill zones. Hunters would hide behind the stones, waiting for the animals to be channeled into positions where they could be harvested efficiently. It is a technique that requires planning, cooperation, and intimate knowledge of animal behavior. One researcher called it a Pompeii-type situation, a frozen moment in prehistoric life. The caribou drive lanes are visible. The hunting blinds are intact. Artifacts have been recovered from the site, including stone tools that date to approximately 9,000 years ago. This is older than Stonehenge by more than 4,000 years, but the most remarkable feature of Lake Huron is not the hunting structures. It is what lies deeper, in the underwater sinkholes. In 2002, archaeologists with the Thunder Bay National Marine Sanctuary were searching for shipwrecks when their instruments detected something unexpected. They found pockets of unusual water at the bottom of the lake. The water was saltier than the surrounding lake water, warmer, and had almost no oxygen. They had discovered underwater sinkholes. Lake Huron sits on a layer of 400-million-year-old limestone, the remnants of an ancient seabed from when saltwater seas covered the Great Lakes region. Groundwater percolates through cracks in this limestone, dissolving the rock and creating caves. Over time, the cave ceilings collapse, forming sinkholes in the lakebed. The sinkholes can be more than 300 feet across and up to 60 feet deep. The water inside them is chemically different from the rest of the lake, high in sulfur, low in oxygen, and rich in dissolved minerals. Nothing from the normal lake ecosystem can survive in these sinkholes. Fish avoid them. The conditions are too extreme, but something does live there. When researchers sent remotely operated vehicles into the sinkholes, they found something extraordinary. Brilliant purple mats of cyanobacteria covered the sinkhole floors, alongside pale, floating, filamentous microbes that look like white ponytails drifting in the water. These are not ordinary microbes. They are cousins of organisms found at the bottom of permanently ice-covered lakes in Antarctica and at deep-sea hydrothermal vents. They use chemical processes that most life on Earth abandoned billions of years ago. When Earth first formed, approximately 4.5 billion years ago, there was no oxygen in the atmosphere. Early life forms, single-celled organisms like cyanobacteria, had to find other ways to produce energy. They used sulfur instead of oxygen. Over time, cyanobacteria evolved the ability to photosynthesize, to use sunlight to split water molecules and release oxygen as a byproduct. This oxygen accumulated in the atmosphere, eventually making the planet habitable for oxygen-breathing organisms like animals and humans. But in the sinkholes of Lake Huron, the conditions mimic the ancient Earth: high sulfur, low oxygen, no light. And the cyanobacteria there have retained the ability to switch between oxygen-based and sulfur-based metabolism. During the day, the purple mats rise toward the light and photosynthesize. At night, the white sulfur-eating bacteria move to the surface and take over. It is a daily dance, a microbial ballet that has been performed for billions of years. Hopi Bidanda, an aquatic ecologist at Grand Valley State University who has studied the sinkholes since 2003, put it this way: these are almost primordial Earth conditions, with high sulfur and low oxygen like in the ancient oceans that covered the Earth 3 billion years ago. Scientists are now using the Lake Huron sinkholes as analog environments to study what life might look like on other planets, particularly the moons Europa and Enceladus, which are believed to have subsurface oceans with similar conditions. The alien worlds we are searching for may have ecosystems that look exactly like what is growing at the bottom of Lake Huron. Lake Erie presents a puzzle. It is the shallowest of the Great Lakes, with an average depth of only 62 feet. The deepest point is just 210 feet. You would think that would make it the safest. It is not. Lake Erie has the highest concentration of shipwrecks per square mile of any of the Great Lakes. According to the Great Lakes Historical Society, the lake has at least 1,500 shipwrecks, and some estimates go as high as 2,000. More vessels have been lost here than in Superior, despite Superior's vastly greater depth and more extreme weather. The answer lies in the physics of waves. In deep water, waves travel in relatively gentle, rolling swells. The energy is distributed over a large vertical distance, but in shallow water, that energy is compressed into a smaller vertical space. The waves become steeper, choppier, and more closely spaced. Lake Erie can go from calm to chaotic in minutes. Storms generate steep vertical waves with very short intervals between crests, sometimes only a few seconds. These waves do not lift ships and set them down gently. They slam into vessels from multiple directions simultaneously. A researcher who studies Great Lakes shipwrecks described it this way: "You can have water as calm as a pond one moment. Then, within minutes, groups of huge vertical waves can be smashing down on you, only seconds apart. The shallowness of the lake actually makes the waves worse." A massive underwater sand spit called Long Point extends into Lake Erie from the Canadian shore. It is one of the most dangerous features in any of the Great Lakes. Long Point acts as a natural trap. Ships traveling along the lake's northern shore can be driven onto the point by storms. In the days of sail, when captains could not simply motor away from a lee shore, Long Point was a death sentence. According to historical records, the waters around Long Point claimed over 300 vessels in storms and other mishaps. Most were wooden schooners, but the toll also includes freighters and fishing tugs. Even today, storms sometimes expose the ghostly ribs and planks of old wrecks on the beaches, only to cover them again during the next blow. Lake Erie's floor is thick, silted mud. When a ship sinks here, it does not rest on a hard surface. It gets swallowed. The sediment closes over wrecks like a blanket, sealing out oxygen and bacteria. Ships that sank in the 1800s have been found with their wooden hulls intact, their cargo untouched, their paint still visible. The mud acts as a natural time capsule. Lake Erie has another problem, one that is getting worse. Every summer, the lake's central basin develops hypoxia, a dead zone where oxygen levels drop so low that almost nothing can survive. Agricultural runoff, primarily phosphorus from fertilizers, washes into the lake from farms in Ohio, Indiana, and Michigan. The phosphorus triggers massive algae blooms on the surface. When the algae die, they sink to the bottom, where bacteria decompose them. The decomposition process consumes oxygen, a lot of oxygen. In the deeper parts of the central basin, where the water stratifies and does not mix with the surface, oxygen levels can drop to zero. Fish cannot survive in these conditions. They swim away to other areas of the lake. But organisms that cannot move, invertebrates, mussels, bottom-dwelling creatures, simply die. In 2012, a strong wind event pushed hypoxic water from the central basin toward the northern shore of Lake Erie. Tens of thousands of fish died along a 40-kilometer stretch of shoreline between Erie and Port Stanley. They had been trapped between the hypoxic water and the shore, with nowhere to escape. On the night of August 8, 1813, 2 American warships were patrolling Lake Ontario during the War of 1812. The Hamilton and the Scourge were originally merchant schooners, pressed into military service and mounted with heavy cannons. The modifications made them top-heavy and unstable, a design flaw that their commanders either did not recognize or chose to ignore. Just after midnight, a sudden squall struck the fleet. The Hamilton and the Scourge capsized almost immediately. At least 53 men went into the water, only 16 survived. The ship sank to the bottom of Lake Ontario, and there they stayed. For 160 years, no one knew where they were. Then, in 1973, a A dentist from St. Catharines, Ontario, named Daniel Nelson, an amateur underwater archaeologist, found them using primitive sonar equipment. What he discovered was, in the words of one Parks Canada archaeologist, basically an archaeologist's dream. The Hamilton and Scourge are sitting upright on the lake floor, approximately 300 feet below the surface and about 1,500 feet apart. Their masts are still standing. Their cannons are still mounted on deck. Cannonballs are still stacked in neat piles, as if the gun crews had stepped away moments ago. Boarding pikes, cutlasses in their racks, personal effects scattered exactly where they fell on that August night in 1813, and the crews are still there. Skeletal remains have been spotted on and around both wrecks. These are war graves, protected under Canadian and Ontario law. Diving on the Hamilton and Scourge requires special permits. Touching anything is prohibited. The cold, dark, oxygen-poor water of Lake Ontario has preserved these ships better than any museum could. They are the closest thing to a time machine on the planet. The Hamilton and Scourge are the only complete War of 1812 warships in the world. Other ships from that era exist only as fragments, reconstructions, or archaeological debris fields. These two ships are intact. They show exactly what armed schooners looked like in the early 19th century, how they were rigged, how they were armed, how sailors lived aboard them. But they're in danger, and now, like every other shipwreck in the lower Great Lakes, they face a new threat. If you drained the Great Lakes today, the bottom would look fuzzy. Every hard surface, rocks, shipwrecks, pipes, docks, even downed aircraft, is carpeted in billions of quagga mussels. These small, fingernail-sized mollusks are an invasive species, native to the Caspian and Black Seas of Eastern Europe. They arrived in the Great Lakes in the late 1980s, hitchhiking in the ballast water of transoceanic cargo ships. They have been spreading ever since. The numbers are difficult to comprehend. Not millions, not billions, quadrillions. An estimated 450 trillion quagga mussels now populate Lake Michigan alone. Every 2 weeks, they filter the entire volume of the lake. They have colonized virtually every surface in the lower 4 Great Lakes: Erie, Huron, Michigan, and Ontario. Only Lake Superior has been spared, and scientists are not sure how long that will last. Recent outbreaks near Isle Royale and in Canada's Nipigon Bay suggest the mussels may be adapting to Superior's colder, calcium-poor water. What you need to understand is every shipwreck is covered with quagga mussels in the lower Great Lakes. Everything. If you drain the lakes, you will get a bowl of quagga mussels. The mussels do one thing extremely well. They filter water. A single mussel can filter a liter of water per day. Multiply that by quadrillions, and you get lakes that are dramatically clearer than they were a generation ago. This sounds like good news. It is not. The increased clarity allows sunlight to penetrate deeper into the water column, changing the temperature and chemistry of the lake bottom. It disrupts ecosystems that evolved in murky conditions. Fish that depended on turbid water for camouflage are now exposed to predators. The mussels are also starving the lake's food chains. They consume phytoplankton, the tiny algae that form the base of the aquatic food web. Without enough phytoplankton, zooplankton populations decline. Without zooplankton, small fish starve. Without small fish, large fish, including commercially valuable species like whitefish, are collapsing. And the mussels are destroying the shipwrecks. The Hamilton and Scourge, those pristine War of 1812 time capsules, are now encrusted with quagga mussels. The mussels stack upon themselves in layers so thick they obscure nameplates, carvings, and fine details. When divers try to brush them off, they inevitably peel away some of the underlying wood. But the physical damage is only part of the problem. The mussels burrow into wooden ships, compromising the structural integrity of hulls and decks. The weight of millions of mussels on already fragile structures is causing walls and bulkheads to collapse. Ships that stood for 100 years are falling apart in decades. And for metal ships, the mussels produce acid as a byproduct of their metabolism. This acid, along with clouds of carbon dioxide and feces, accelerates corrosion of iron and steel. Michigan State maritime archaeologist Wayne Lusardi has documented the damage across dozens of shipwreck sites. He is also racing to recover pieces of a World War II aircraft, a Bell P-39 Era Cobra flown by Tuskegee Airman Lieutenant Frank Moody, who crashed during a training mission in Lake Huron in 1944. Divers started discovering planes in the 1960s and the 1970s. Some were so preserved they could fly again. Now, when they are removed, the planes look like Swiss cheese. No one has found a viable way to stop the mussels. Parks Canada has been monitoring the situation at the Hamilton and Scourge. Scientists have experimented with removing mussels from small reef areas, but at the scale of the entire Great Lakes, there is no practical solution. The mussels are everywhere, and they are not going away. The Great Lakes preserved these ships for centuries. Now, an invasive species the size of your thumbnail is undoing that preservation in decades. We are losing the history at the bottom of the lakes faster than at any point in recorded time. The Great Lakes are not just water. They are a record, a vault, an archive of everything that has happened on this continent for the past 10,000 years, and in the case of the Lake Huron sinkholes, for the past 2.5 billion years. The volcanic rifts that nearly tore North America in half are down there, preserved in the basalt cliffs of Lake Superior. The prehistoric hunters who walked the exposed lakebeds during the Ice Age, their stone hunting lanes are still standing, exactly where they built them 9,000 years ago. The sailors who fought wars, transported cargo, and were swallowed by storms are down there too. Their ships, their belongings, sometimes their bodies. The chemistry of the ancient Earth is still thriving in underwater sinkholes, purple and white bacterial mats performing a daily dance that has gone on for billions of years. All of it hidden beneath the surface. All of it waiting. The lakes have been guardians of this history. The cold, the depth, the darkness. These conditions preserve things that would have been destroyed anywhere else. The Great Lakes are one of the few places on Earth where you can see a wooden ship from the 1800s that looks like it sank last week. But that is changing. Invasive mussels are consuming the shipwrecks. Climate change is warming the water, potentially making it more hospitable for species that do not belong. Pollution and agricultural runoff are creating dead zones that kill everything in their path. The vault is being breached. Archaeologists and historians are racing to document as many sites as they can using sonar, remotely operated vehicles, three-dimensional imaging, before the mussels destroy them. Every shipwreck they find is one more piece of history saved, even if only as a digital record. But there is no way to document everything. An estimated 6,500 ships have sunk in the Great Lakes over the past 300 years. Perhaps 25,000 if you include smaller vessels. Many will never be found. Many more will be lost to the mussels before anyone reaches them. The surface of the lakes changes every day. Waves roll in, ice forms and melts, storms come and go. But the bottom was supposed to be different. The bottom was supposed to be eternal. It is not. The vault is closing, but what is still inside, the ships, the stones, the sinkholes, the bodies, tells the story of this continent like nothing else can. And now you know what is down there.